Now it's time to come back, circle back, and revisit the what do you think question. How does an airbag protect you during an accident? Hopefully by now you can start to put some of that physics vocabulary into your explanation using words like work and displacement and force, all of that good stuff. For these problems, we've got these practice problems. Let me get out of your way. There we go. Let's look at number 2 together, just to be on the safe side, make sure we're all on the same page here. If you triple the speed from 20 kilometers an hour to 60 kilometers per hour, by what factor does the kinetic energy change? Well, we know that kinetic energy equals 1/2 m times v squared. What we are doing is we're tripling the speed, so we are tripling the v, right? Well, if we're tripling the v, then that 3 is also going to be squared, as well as that term. So that means this is going to be 9 times your velocity squared, which means your kinetic energy has now increased, because this is an equal sign. Whatever we do to the right, we have to keep to the left. 9 times the amount of kinetic energy. So 9 times. The following table, this number 5 right here, let's take a look at that. Copy and complete the following table. First row has been completed for you. All you're doing is just plugging in, you're just getting some experience using this equation, k equals 1/2 mv squared. How much kinetic energy does this person have down here for number 6? You have m and you have v, so you can get that. How much work is required to stop the person, so you know you're coming to a stop. You're looking for work, probably. That work equals the change in energy, right? And then the force required would be the other work equation. 7, you should be able to handle without too much of a problem. And then for 8 is a multiple choice question. So you have your mass, you have your amount of kinetic energy, and you're trying to figure out which is the correct speed. Hint there is to remember that it's going to be squared. One final example. We've got a 3 kilogram car traveling at a constant 2 meters per second across a level table 1.8 meters above the floor, and it stopped in a distance of 0.3 meters. The amount of work required to stop the car is what? Alright, so first thing I'm going to do is I'm going to draw it out, because this sounds difficult. You've got a car, and it's going to the right at 2 meters per second across a level table, and that table is 1.8 meters above the floor. That distance doesn't really matter. We don't really need that. It's stopped in a distance of 0.3 meters. So the only distance we care about is this 0.3 meters right here. The amount of work required to stop, we have mass, we have velocity, we have distance, and we're looking for work. So which equation or combination of equations is this going to deal with? Well, we know work equals force times displacement. Work also equals your change in kinetic energy. And we know the ending kinetic energy, Vf equals 0, so the ending kinetic energy is going to be equal to 0. So I would say, let's use that. Work equals our change in kinetic energy. So we have our final kinetic energy, which is 0, minus our initial kinetic energy. So that goes away. The amount of work is what we're trying to solve. And we have 1/2 mv squared. Here we go. What's happening? 1/2 mv squared here. Now, you may be asking what happened to the negative. Remember last time we did this, we had a negative. Because we're stopping, there would be negative work. So you could imagine this was a negative work, and I moved it to the right, and then the negative kinetic energy, and I moved it to the left. I just switched them. And now we can plug in our information. Half of 3, because the mass is 3, half of 3 is 1.5. The velocity squared, which is 4. The amount of work being done is 1.5 times 4. So 6 joules of work. Nothing too crazy yet. But now let's look at it and see what happens if we change something. So what happens if the force required is halved? If the force required is halved, then what this would become is 6 was our work required. Force is halved. Oh, what happens to the force? So force we're trying to see, and the distance is halved. So half of the distance. The distance was 0.3, so this is going to be 0.15 times F equals 6. Divide 6 by 0.15, and you get force equals 40. Okay. What was the original force? How did it change? Well, F equals work over displacement, so 6 divided by 0.3. It's 20. So by halving the distance, we have increased the force by 2. Doubled the amount of force required because we have halved the stopping distance. We covered this before, earlier in the year when we talked about driving on roads that were wet. It's harder to get a car to stop if it's already moving forward. What happens if we double this distance? So now it's going to be 6 divided by 0.3 times 2, which is 0.6. So now our force is 10 newtons. So here we go. So the original force, there it went. Anyway, the original force was 20 newtons. When we doubled the stopping distance, we got to 40 newtons. And when we have the stopping distance, we got to 40 newtons. And when we doubled the stopping distance, we got to 10 newtons. So you see how the force changes. Now, what happens to the work if the stopping distance is halved? Remember, work equals force times displacement. So we know the original force was 20 newtons, and the distance was 0.3. So the original work equals 6. So now we're keeping force constant, and we're seeing what happens to work as we changed our distance. So now let's halve the stopping distance. So we still have 20 newtons for the force, and then half of 0.3 is 0.15. 20 times 0.15 is going to be 3 joules of work. So our work goes down because our stopping distance went down. So we're not able to apply that force for the same amount of distance, so we're not able to do as much work, is what that means. We're not able to get that energy out. What happens to the work if the stopping distance is halved? Or doubled. We did halved. Silly. 0.6 times 20 is going to give me 12 joules of work. So the work would then double. If the distance doubles, then the work doubles. If the distance is halved, then the work is halved. Hopefully by now you understand why it's so important to make sure you're in a car with the proper airbag feature.